Ladies and gentlemen, GCU-ACM Student Chapter would like to welcome you all to our virtual ACM Distinguished Speaker Talk on Collected for Profit, Repurposed for Social Good, Using Advertising Data to Support Global Development. With great pleasure, let me introduce our guest speaker for today's talk, Dr. Ingmar Weber. Dr. Ingmar Weber is the Research Director for Social Computing at the Qatar Computing Research Institute. As an undergraduate, he studied mathematics at the Cambridge University from 1999 to 2003 before pursuing a PhD at the Max Planck Institute for Computer Science from 2003 to 2007. He subsequently held positions at École Polytechnique Fédérale de Lausanne 2007 to 2009 and Yahoo Research Barcelona from 2009 to 2012, as well as visiting researcher position at Microsoft Research Cambridge in the summer of 2008. His interdisciplinary research uses large amount of online data from social media and other sources to study human behavior at scale. Particular topics of interest include studying obesity and population health, quantifying international migration using digital methods, and looking at political polarization and extremism. Now, without any further delay, let's hear from our guest speaker, Dr. Ingmar Weber.
Great, thank you so much for the introduction, and thanks for the invitation to present my work. It's a great pleasure and honor to present. So let me go ahead and share my slides. Right, so yeah, also thanks to ACM for connecting us and for giving me the opportunity to present. So yeah, so I'm sure you're familiar with ACM. It's the biggest organization of people working in computer science, and I'm a proud ACM member. And also ACM has a program called the Distinguished Speakers Program, through which I was invited to present my work. So the work that I will be presenting is joint work with a number of fantastic collaborators. So here at the Qatar Computing Research Institute, there's my colleague Joao and Masumali. Also a crucial contributor at the University of Oxford is Ricky Kashyap. But there are many, many others, both at QCI as well as at other universities, as well as UN agencies who've contributed to this line of research over the past several years. So let's start with a slogan that you've probably heard of, right? So if you're not paying for the product, then you are the product, right? So for example, websites such as Facebook, or also services such as Google, typically they don't charge you for their services, right? But that means that in return, you are sort of paying them through your data, right? So they as you use them, they sort of collect data about you, right? And then this information that they collect is then used to build up certain user profiles about you with certain attributes. And then advertisers can use these attributes to target their ads. Okay, let's give a specific example. So for example, I can go to Facebook's advertising platform, today and say, I would like to launch an advertising campaign targeting only female Facebook users living in London, aged 25 to 29, who lived in Poland, right? So who have a migration background, and to use an iOS device, right? And so typically iOS devices are more expensive than Android devices, as we'll also see later in the talk. And then importantly, before I launch my advertising campaign, and so before I have to pay anything, Facebook provides so-called audience estimates. So typically these are used for campaign planning or for budget planning, right? It makes a difference, like, are there 100 people matching these criteria? Are there 1,000 people, 10,000 people, 100,000 people, right? I mean, depending on how many people are matching my criteria, I might run a very different type of advertising campaign, right? And so in this particular example, Facebook tells me upfront, so before I have to pay anything, that there are 2,600 monthly active users matching my targeting criteria. So this effectively gives me a no cost, because I don't have to pay anything, real-time census over almost 3 billion Facebook users. And that includes sort of Instagram and Facebook Messenger, etc. So yeah, in my work and in the rest of this talk, I also look at how we can use such data to monitor international development. So I'll actually like to show you Facebook's advertising platform live. So I'll briefly switch to a different screen. So here, what you can see is Facebook's advertising platform. So this is publicly accessible, free of charge. Right. So this, I want to make this very sort of clear. So after this talk, you can just follow the steps. You just Google how to launch an advertising campaign on Facebook, and eventually you'll get to this screen, right? Until you get to the step of launching the ad, it's completely free, right? So far we are just sort of planning an ad campaign, right? So everything you see here is accessible for free. So here I'm, sort of at the planning stage of an advertising campaign, targeting people living in a particular location. The location I've selected so far is Norte de Santander, which is part of the country of Colombia. Okay, so let me just zoom out a bit for sort of context, right? So we have sort of South America here. Here we're looking at part of Colombia with the country of Venezuela in the east. And why that's relevant, we'll get to in a second. So far, my targeting criteria are very broad, sort of just age 18 and above, all genders. Okay, and at this stage, Facebook tells me here on the right how many people match my targeting criteria, right? Sort of up to 1.1 million users, or to be more specific, monthly active users, right? So this is an estimate that Facebook provides on how many of its users log into the service at least once a month among those who match the targeting criteria. Okay, so that's interesting, and I can look at, for example, at what is the gender distribution among these people, right? So it's a sort of fairly gender balanced, right? So it's at the upper end is 520,000 men, as opposed to slightly more women. Okay, that's interesting, and in some of our work we look at this gender data separately. But now in this particular context, there's another targeting criteria that's interesting, and that is relates to countries people have lived in before. Right, so now I can look at of these 1.1 million people, how many previously used to live in Venezuela, which is the country in the east, right? And you see that a fairly substantial chunk, right, like maybe 15% or so of Facebook users who are currently living in this part of Colombia used to live in another country in the past, right? And so again, 15% of the population is quite a significant sort of chunk, and this relates to the fact that there's a still an ongoing sort of economic and political crisis in Venezuela, and many people have fled the country. Now, beyond going this sort of very sort of broad targeting, again, you can also be still even more specific, and you can look at the devices that people use to connect to Facebook. So as you also see later, that in a nutshell, iOS devices are typically more expensive, and so knowing what percentage of this 160,000 people have access to iOS devices indirectly tells us something about their sort of socioeconomic situation, right? And so here's a fairly small percentage, right? And so this is sort of something that we can sort of look at. And again, you can do this anywhere in the world. Right? So maybe I'll just very quickly show you. Maybe not this one. Let me show data for sort of the country level for Pakistan, for example. And you can do this at the city level or even at the sub-city level. Just sort of we remove this other sort of thing. So now for all of Pakistan, there are about 42 million Facebook users. Now, if you look at the sort of the gender distribution among those, so here you see this heavily skews male, right? And this is for us something that we look at in our data, because typically these sort of gender gaps on Facebook represent gender gaps more widely, in particular gender gaps in terms of internet access more broadly. So let me show you some data visualizations around this data to maybe explain in even more detail what you can do. So here's a data visualization that we created around data that was collected about 5 years ago from Facebook. So this is not Facebook live data, right? So the data was provided through this advertising platform, and the data visualization is ours, right? So we would sort of 5 years ago we would sort of query Facebook sort of to ask, in this zip code in New York City, how many women with a university degree are in this age range who used to live in Latin America and are using an iOS device, right? So this would be sort of one data point that contributes to this sort of data visualization. Okay, so now what can we do with this visualization? For example, if you wanted to understand the wealth distribution in New York City as a sort of first order, you can look at the distribution of iOS devices. Right? So now you'll sort of see here in a sort of, this is Manhattan, and this is sort of Midtown here. This is sort of the banking district. So here you'll have about 90% of Facebook users connecting to Facebook through iOS devices, right? Very, very high percentage. On the other end, you have sort of here, this is the Bronx, where it's only about sort of 40% of Facebook users using iOS devices. I mean, 40% is still significant, but clearly, there's a wealth differential between these two areas, which is sort of true, right? I mean, if you're sort of familiar with New York City, you probably, or even, you might have known before that, the Bronx is probably not as rich as sort of Manhattan, right? Sort of also. And then this you could find out through other data sources as well, right? You can also look at a sort of migration background. So if you look at where do people live now, I mean, again, the data is from 5 years ago, who used to live in Latin America, you'd see that the density is highest in sort of parts of the Bronx, where about 40% of Facebook users, in the past used to live in Latin America. And again, if you're sort of, familiar with sort of, demographics of New York City, then this is sort of, that this is true. Now, in the case of New York City, you have open government data, you have sort of census data that you can sort of download. So I'm not telling you anything you can't find out through other means. But in other parts of the world, that's not the case, right? And this includes the city of Doha that I'm in at the moment. So Doha does not have zip codes. And so this is why you sort of here for targeting, sort of we use these sort of custom sort of circles where basically we provide latitude and longitude with a certain radius around, right? And so now suppose you wanted to understand the demographics of people, in the wider sort of Doha area, right? Maybe let's start with people who used to live in Nepal. So people who used to live in Nepal, they're mostly found in the so-called industrial area, which again, living here I can test is true, but in this particular case, you would already not find sort of open government data on this issue, right? But if you Google industrial area Doha, you would sort of see that this area was built to house people from South and Southeast Asia, right? Sort of, so certainly sort of plausible to say the very least. They're almost all men, and this relates to the fact that they are sort of blue-collar construction workers, right? So there are a lot of young men from, South Asia, sort of here, sort of building, stadiums, which is now sort of finished for the World Cup, but also sort of a lot of other sort of construction sites. They're fairly young, as I already sort of mentioned, sort of also, which is a blessing during COVID times, because almost all of them, were affected with COVID at some point, but there were only very, very few fatalities because by and large, they are young and healthy. And they are almost, very, very few iOS users, right? So they're almost all using Android devices because typically those are sort of cheaper and more accessible. Now you can contrast this with people from other backgrounds, right? Sort of such as myself. So I'm originally from Germany. So people. So first, in terms of location, right? It's a completely different part of town. So this is where I live. Again, sort of quite typically. So this is an area with a lot of sort of high rises, sort of. So also where it's sort of more expensive to live. I live there with my wife, so I can bring over my wife and our daughter. But for that, you have to make a certain minimum income to get a family visa. So sadly, not in most construction workers from Nepal would not clear that threshold, right? So I'm a university graduate, as is sort of typical for people such as myself. I'm still in this age range, but I'm approaching this age range. And you have more older people, right? Because these are sort of knowledge experts, right? Like if you're working in my position, it doesn't really matter if you're young or old to some degree, right? So you have sort of older people coming in, and you have more iOS device users than Android device users. I mean, personally, I'm using an iOS device, but so an Android device, but I could certainly theoretically afford an iOS device, right? And so this is sort of in broad strokes already sort of paints like a picture of the very different sort of situation of life of somebody from Nepal or somebody from Germany who's now living in Doha. And again, conceptually, you can do this anywhere in the world as long as you have sort of pre-collected data. So I'll just show one more example. This is now the city of Lagos, where maybe again, let's look at the device types. So the density of iOS devices is highest in this part of Lagos. This is Lagos Island, and this is where the government is located. So around the seat of the government, you have about sort of 15% of Facebook users using iOS devices. This now drops from 15% to around sort of 7 and something sort of percent in the rest of sort of Lagos, and it drops sort of further from sort of 7% to maybe 4 or 5% in the sort of outskirts, right? And so based on this, you would probably assume that there's more wealth, around the location of the government, and then sort of, lesser in the rest of sort of main Lagos, and then even lesser in the outskirts, right? And this is probably true, but here's now even the sort of the ground truth data is already sketchier. Now, I assume that many of you are sort of, computer scientists or sort of data scientists. So I also want to briefly show you a bit of how the data collection actually works or what it looks like. So basically, you don't have to do any sort of screen scraping. Facebook provides a very nice API called Graph API, right? And if you sort of make a request to this API, you get back something that looks like this, right? So this is just a bunch of sort of JSON data, right? And this sort of JSON data contains a bunch of sort of things. I'll just hide those for a second. But importantly, you get these things back, right? So there's an estimate MAU. This is the estimate of monthly active users, and an estimated DAU, the estimate of daily active users, right? And this is what we're using in our work. There's also things on this, for example, this sort of daily outcomes curve and sort of other things that where Facebook tries to estimate how many people you will reach in response to how much you bid or how much money you spend. That we have not yet analyzed, but I think it might be interesting to analyze because it tells you, among other things, whose eyeballs are more expensive, right? So maybe, for example, in Manhattan, it's probably, I would guess, I haven't tested this, but I would guess it's more expensive to run an ad in Manhattan than it is to run in the Bronx, right? And maybe it's more expensive to run an ad targeting people, using an iOS device who are interested in finance in Manhattan, right? So this is, so you say, sort of bankers, than it is to sort of targeting people, using an Android device, I don't know, in the suburbs of New York City, or something, right? And so this might be interesting to look at. Now you can either collect this data using the sort of the Graph API directly, or we've also sort of working with the World Bank, we've created a wrapper API that you can use. So one of my collaborators spent time the World Bank sort of putting together a nice sort of tutorial how to collect such data for Facebook, but also how to collect such data for LinkedIn. So anything that has targeted advertising has a platform like this, right? So if you think, oh, Facebook is, I don't know, going out of business now, it's all Snapchat or TikTok or whatever. Well, as long as it has advertising, it has a platform like this. And just to show you what the code then looks like, it's even easier. You just provide a bit of JSON where you specify, for example, the locations you want to target. In this case, it's sort of 2 countries, Brazil and Italy, the genders and the age range. And then you provide this together with an access token that you have to create. And then, the library or the code goes and collects data and returns then a sort of data frame with a sort of data returned. Okay, so let me go back to the presentation, but hopefully that made it very clear what sort of data we're talking about and how such data can be collected programmatically. Okay, so okay, and on the presentation, great. So now, what do my days now clicking through, I don't know, Facebook data from Doha or something, right? So to understand, right? Most of my work looks at data related to international development, right? And so what's wrong with traditional data on international development, right? We're not the first to try to collect data on issues such as poverty. Well, broadly speaking, there's sort of 3 challenges, facing traditional data. So one relates to the speed, right? So often traditional data use comes from the census, and most countries run the census every 10 years, right? So sometimes there are gaps. I think in Pakistan there was one census in 1998, and then another one in 2017. So there was a 19-year gap, and I think in Pakistan the next upcoming in August, if I'm not mistaken. So there's only like a 5-year gap, right? Sort of, but usually it's sort of like a 10-year gap, and then there's another like 1 or 2 years, sometimes even until the data is sort of available to be analyzed, right? And so this means, and often, you have data that might be 5, 6, 7, or even more years out of date. Even when data is available, sometimes it's quite coarse, right? So, for example, you have the national data available like for the province of Punjab, right? But if I'm not mistaken, I think the population of Punjab is like 110, 120 million people. And so if you have like one data point for like 110 million people, that's not very meaningful, right? It's just sort of, it's a huge area with a lot of people. So sort of summarizing that in a single number, probably not very actionable, right? And then even if it's more spatially fine-grained, it often aggregated across different demographic groups, right? So, for example, we are interested in looking at sort of wealth estimates that are separate by gender, right? So maybe assets are available to a household, but they're all under the control of the male head of household, right? So then maybe on paper it looks as if there's maybe not a significant poverty level. But again, if all those assets that are available are only accessible to sort of the male population, then that's an issue, right? And so how can we sort of have sort of poverty estimates, for example, that are gender disaggregated? So yeah, in a nutshell, that's what we are sort of trying to do, right? We try to combine this new data with existing data. We're not saying throw away traditional data, but we're sort of trying to sort of use data from Facebook and also other sort of non-traditional data sources to help improve data recency, to help improve spatial granularity, and to help improve demographic disaggregation. So in the rest of my talk, I'll elaborate this sort of by looking at sort of 3 particular examples of work that we did in the past. So one looking at international migration, one looking at poverty, and one looking at digital gender gaps. Okay, so the first work I talked about was joint work, in particular with people at UNHCR, UNICEF, and IMAP. IMAP is a small NGO that does information management related to humanitarian development and disasters. So just a bit of background about the situation in Venezuela, if you're not sort of familiar with it. So in 2019, according to the International Monetary Fund, Venezuela had an annual inflation rate of 10 million%. It's not a typo, it's really 10 million, right? So this is so-called sort of hyper inflation. Estimates of unemployment of upwards of 40%. Importantly, if you were earning minimum wage and you would pay, every single, I believe it's peso, the local sort of currency, on food, you could only afford 1,000 calories a day, right? And I'm sure you're aware, you typically need sort of 2,000 to 2,500 calories to sort of basically stay alive, right? So many people were literally starving under what's sometimes called the Maduro diet. In response, a significant percentage of the country has actually left. So 15 to maybe 20% of the country has left Venezuela over the last 7 years or so. Mostly into neighboring countries, including sort of Colombia, that we saw already neighboring Venezuela in the West. Now, when it comes to how many people exactly and where they are now, data is not always very accurate, sort of, like especially sort of close to the migration event, right? So once there's a census done, typically sort of data quality improves, but until like the next census round, it's often not clear, because often it's based on voluntary sort of self-registration data, and that might miss certain groups. Okay, so what is it that we did in this context? So we collected this data from Facebook across time, right? So previously I showed you like how many people like today, right, are on Facebook who previously lived in Venezuela, in a particular part of Colombia, and we would sort of collect this over time, starting regularly from sort of summer 2018. So let me try to explain what this sort of graph shows here. So first, in red, I'm showing data for Colombia as the host country. So the country of origin is always Venezuela. We're always looking at users from Venezuela who lived in Venezuela who are now living elsewhere, right? So in red is now living in Colombia. This data point here is just the raw number of monthly active Facebook users who lived in Venezuela, at the time of collection. Right? So this is what I showed sort of previously, I think, where it was like 160,000 for part of Colombia, but this is the number for all of Colombia, which at that point was just around sort of 1 million. Now, if we assume that every single of these Facebook users is actually a Venezuelan, migrant or refugee, then this is an underestimate, right? Because of course not everybody is on Facebook, right? So the Facebook doesn't have 100%, penetration. I mean, even among sort of users who are old enough, right? Let alone sort of children and others, right? And so, okay, so how do we sort of correct for this? Well, we now make a simple assumption, right? We assume that the Facebook penetration among the Venezuelan migrants in Colombia is the same Facebook penetration as among the Colombian host population. So, okay, so how does that work? So basically we look up, okay, what's the population of Colombia? Of that population, how many are on Facebook? Okay, so we can compute sort of the population of Facebook penetration of all of Colombia. Suppose it's 60%. And then we sort of add the missing 40% on top, right? So this now gives us this upper estimate, which sort of corrects for non-Facebook users, and again assumes the same Facebook penetration as in Colombia in general, right? And so again, if there are no false positives, then this is sort of probably close in some sense to what's like a plausible value. So okay, so and then we monitor this over time and sort of collect data and sort of and report this to different UN agencies. Now, how does this compare to sort of ground truth, right? And I'm deliberately putting sort of air quotes here. So let's look at these estimates here. So these estimates here are now for all of Latin America. So this you have to compare to this sort of numbers in gray that you see here. They come from two different UN reports that collected data across two different sort of time periods. Right? And you sort of see that the numbers are broadly in line, right? But probably, especially if you look at the upper estimates, that the estimates derived from Facebook are probably higher than those from the UN report. Right? And that's plausible, and it's also quite typical that often official estimates are sort of at the lower end. But it's also interesting that even between these different reports, there are already sort of inconsistencies, right? Because they're sort of using different methodologies, right? So again, ultimately, we don't know for sure, but at least these estimates sort of that you get are at the very least plausible. Let's look at it in a bit more detail by zooming in just on one host country, but the most important host country, which is sort of Colombia. So here on the left, I'm showing data that the Colombian government collected in sort of spring and summer 2018. So this data was based on voluntary sort of self-registration, right? Where basically sort of Venezuelans were sort of asked to please come and register themselves. On the right-hand side, you see the same sort of data collected from Facebook around the same point in time, sort of June 2018. Now we see some sort of similarities, but also some differences, right? So both of these data sources pick up a significant number close to the border, right? Like for example, in Norte de Santander, which is what I was showing earlier. But then in particular, Facebook sort of picks up, likely to be migrants also further away from the border, right? Sort of also including in the capital, Bogota. And so now it's a question of, okay, who's wrong, who's right? So I sort of, right? And in a sense, this is on the left is official government data. This is, as good as it gets in terms of sort of ground truth data for this particular setting, right? But then because we were actually working with people in Colombia, they actually told us, what, this data from the right is actually more plausible, right? Because they actually did observe also significant numbers of Venezuelans sort of further away from the border, right? And their hypothesis was that the self-registration efforts were more pronounced closer on the border, right? Sort of, so that many people probably were missed by the sort of self-registration away from the border. So again, ultimately, we don't know for sure. So what's the sort of the ground truth? But at least anecdotally, the data on the right derived from Facebook is at least as good and likely to be better than the data collected by the Colombian government. For other countries, at least at the time when we did this, there was no subnational data available. So this data was the only source of sort of subnational estimates. Briefly mentioned the case of Brazil, where we also picked up a non-insignificant number of Venezuelans further south in sort of Sao Paulo area, And this then led UNICEF to adjust targeting of an anti-xenophobia campaign they were running. So initially they were planning to target only the northern end of the country, but then they actually adjusted it to also include the sort of the southern part of the country, based on this signal that there seems to be also Venezuelans further south. Great. So that's all, jolly good, right? So while this situation was sort of ongoing, right, we could have like regularly updated estimates of, sort of Venezuelans across space and time and sort of. But we could even do more than this, right? We can look not just at the total number of Venezuelans, but we could also try to understand their sort of socioeconomic situation. We did this by looking at the device types that they use to access Facebook. So how does this work specifically? So let's look at this diagram here. So again, every location you see here is a host country or host location. We're always looking at people from Venezuela, and they are now sorted by the percentage of iOS usage. Okay, let me try to explain this. So on the very left, where it says Roraima, Brazil, this is part of the sort of jungle that you would sort of typically walk. You could cross into by walking from Venezuela, into Brazil, right? And in this part of Brazil, only 3% of Venezuelan migrants were using iOS devices, right? So quite a low percentage. At the other end of the scale, people who made it all the way to the United States, for them, actually, the majority of them were using iOS devices, right? So this sort of induces this order of, likely to be poor to sort of likely to be, if not rich, at least sort of less concern, let's say, right? Now, how do we get the actual sort of height of these bars, right? There's some sort of dollar estimate on the y-axis, right, where it says predicted GDP per capita. So the way that this works is that we train a model to predict country level per capita GDP using only the percentage of iOS usage among Facebook users as a signal. Okay, so for example, let's imagine that in Chile overall has maybe a per capita GDP of, let's say, $25,000 US. Okay, and let's imagine that sort of Chile has a percentage of iOS users of 20%. Right, like sort of, right? So then we collect sort of such data, sort of also at 20% mapping to $25,000 US per capita, right? Sort of also for all the countries in Latin America, and then we train a simple regression model that just uses this one variable, right? So the percentage of iOS usage to predict the outcome variable, which is the per capita GDP. And this single variable, does really, really well. So it explains, almost 90% of the variance in per capita GDP. And this model is then used, right, to make these other predictions, right? So now we have a mapping, right, that maps maybe 20% to $25,000 US per capita, right? And so then this would be then applied to these sort of different sort of things, right? So then, okay, maybe then 3% maps to, I don't know, $4,000 US, right? So that's how this works. Now, the precise height of these bars might not be, very precise. However, in all of our analysis, we always observe that there are sort of these three groups that emerge, even if we sort of try different variants of sort of model specifications, etc. That way we are more quite comfortable, I would say, saying that people who make it only the way only to sort of Colombia or Brazil in general, right, so that they are probably worse off in terms of socioeconomics than people who make it sort of Argentina or Chile, who in turn are probably worse off than people who make it all the way to Spain or the United States. And again, this sort of general finding that iOS uses sort of predictive of sort of wealth, we'll also see sort of later in the presentation, but we've also seen it apply to, for example, Syrians in Lebanon. We are going beyond the analysis. We were pleased that again there was operational impact, and that it continues to be used. This collection analysis of Facebook data, in particular through this NGO called IMAP, who sort of continue to work with different partners, including USAID, on analyzing the situation, in Colombia and other sort of countries in the area. Now, it's not all good news. It's not, this is now like the magical wand that sort of fixes, migration statistics. There are certainly also challenges when you work with this sort of data. And so here I'll show you one of the drawbacks. So what you're seeing is a very, very, very simple and crude sort of, data visualization that we created for UNHCR while we were sort of, analyzing this data. And so here it shows data for Brazil as a host country. And just look at the sort of the top, which is the total number of sort of migrants, from Venezuela. Okay, and then you see the sudden dip, right? Like before it sort of goes up and up and up, and then it suddenly goes down, right? Sort of so like in March or sort of so 2019, right? And so okay, so what was going on there? I mean, were people returning home to Venezuela, or were they sort of continuing onwards to Argentina or sort of to elsewhere? Why would there be a dip? Well, it turns out that this is not real in a sense, but that this is actually a change in Facebook's algorithm, right? So that Facebook from one day to the next sort of changed how they detect whether somebody used to live in Venezuela or not. How do we know, right? How do we know this is not real? Well, we only know because we are collecting this data regularly, just for sort of all host and origin and destination countries worldwide, right? And so we saw for all combinations around the same time a dip, right? Not just for Venezuelans in Brazil, but also for Germans in Italy or so, right? And given that it's like, globally around the same time, sort of for some, we are very, very confident to sort of state that this is change in Facebook's algorithm, right? And there's of course that's now a challenge, right? We are already sitting on top of this sort of black box, right? We don't know exactly how Facebook knows whether somebody used to live in Venezuela. I mean, we can speculate, but we don't know for sure. So it's a black box. And then furthermore, this black box is not even stable across time, but they can of course change it any day, right? Like if they think, oh, this new change is better for our advertising revenue or something or so, then yeah, they might do so. Right? So this is one of the sort of key challenges of operationalizing such data. Okay, so that was one of the examples looking at migration in particular. I want to talk about two other examples. One that looks at mapping poverty, and this is joint work with UNICEF and a data science company called Thinking Machines, which is based in the Philippines. So, okay, why do we care about measuring poverty? So the goal of eradicating poverty, right? This goal of no poverty is one of the 17 sustainable development goals. When it comes to measuring poverty, there are different approaches. So the UN typically uses an income-based approach that defines a person as being extremely poor if they earn less than $1.25 per day. But there are also other approaches, for example, that look at asset ownership, which is one of the things that we'll actually be doing for this work. When it comes to recency of available data, I already hinted that at that before. So often it's outdated because often it's tied to the last census data being available. And even if it is available, then often it lacks sort of spatial granularity, because ideally you would like to analyze data even at the sort of sub-city level, right? Like if you want to run an intervention. And so so we're interested, okay, can we actually use data from Facebook to build better poverty maps, right? So how does this sort of work? Well, in a sense, it's just a normal regression task, right? Like so what does it mean specifically, right? So it starts with some sort of ground truth data that we can sort of use for model training, right? In our case, the ground truth data is the so-called wealth index that's provided by the Demographic and Health Survey, which is something that USAID runs in a number of countries every couple of years. Right? And in this survey, they ask about asset ownership. So they would, knock at somebody's door and ask, okay, how much stuff do you have? Right? I mean, or more specifically, they would ask, like, do you have a fridge? Do you have running water? Do you have a mobile phone? Do you have a motorcycle? Et cetera, right? And then all these answers of a household are sort of compiled into a so-called wealth index, which is just doing a sort of principal component analysis to come up with a single number, where a large positive number means that this household has a lot of stuff, and a large negative number means this household doesn't have a lot of stuff. And then these wealth indices are further sort of aggregated at the so-called sort of cluster level. Like a cluster is just another term for like a surveyed location. Think of it like as a village or like a small part of a city, right? Where they would sort of pick about sort of 20 households, and they would sort of ask these sort of 20 households, and then would aggregate their answers into a single wealth index for that surveyed location. So that's sort of the target. So we have this data for some locations, but we would like to improve the coverage for all the other locations that were not included in the survey, right? And sort of to do this sort of extrapolation, we would like to explore how much value Facebook data adds to this, right? And so, for example, one feature that we looked at is the percentage of Facebook users of the total population, right? Or just the Facebook penetration, right? So if we know this village has, I don't know, 10,000 people or so, and of those 1,000 are on Facebook, right? So then so 10% Facebook penetration. But for that, of course, we need to know the population of sort of the fairly small level. And for that, we use existing estimates derived from satellite imagery. So there are sort of these high-resolution population maps that you can sort of download that tell you, sometimes even down to like a level of like 100 meters by 100 meters of how many people are estimated to live in a small area. And so this is one of the features, so the Facebook penetration, but also we look again at sort of the iOS usage, right? Like if we see, in this location, a large percentage of Facebook users are using iOS, that's another sort of signal, or they're using Wi-Fi to connect, or they're using 4G to connect, right? All of these are sort of different signals that might potentially be predictive of spatial variation in wealth. And then once we have sort of the ground truth data, and once we have sort of our predictor variables, it just becomes a standard regression task, right? So you try to predict this variable sort of using a bunch of features, right? So then you can just plug into your favorite regression model. We try different sort of models. Empirically, sort of gradient boosting machines work best, but again, you could try your own model and see how well it performs. Okay, so now how well did it actually perform, and how does it actually beat a baseline? Right? What would be something meaningful to compare against? Right? I mean, we're not the first to sort of try to map poverty, and so what would we use in absence of Facebook data? So one baseline you can use is it's just sort of the interpolation of existing data. Right? So for example, suppose you want to make a prediction for a location where you don't have data from DHS, but you have data from DHS for sort of surrounding villages, right? So then you could just look at, let me just average, the nearest neighbors, and that's my prediction, right? And that actually turns out to work fairly well, right? So here you sort of see the performance for this, right? So for example, in the Philippines, this is now out of sample R squared, right? So it explains almost 50% of the spatial variation is explained basically by looking at your neighbors, right? And in India, this goes up to almost sort of 2/3, right? So there's more spatial autocorrelation, I put in different terms, right? Which makes sense, right? These sort of, it's not that, like every village is sort of different or every location is different, right? Typically, there are bigger areas that are sort of poor or rich, right? And this sort of makes the sort of looking at the sort of the neighbors a strong baseline. Then, okay, so how does this baseline now perform or sort of compared against sort of using only features from Facebook, right? Including the Facebook penetration, for which you need also the offline information about sort of population distribution, right? And you see in the Philippines, this now actually, improves on this baseline, right? It goes to sort of about 50%, about sort of 60% of variance explained, right? In India, it actually does not perform as well, right? So in India, just using the spatial autocorrelation is a stronger baseline, right? Then if you bring in additional sort of features, it improves further. And so, for example, one of the features is now a regional indicator. It's just like a dummy variable, right? So maybe in the Indian context, I don't know, Tamil Nadu is different from Kerala, right? Like in terms of sort of poverty dynamics and the mapping between iOS usage and absolute levels of poverty, right? And so if you include a dummy variable in the model, right? Like, are you in Tamil Nadu or not? Then that sort of affects, that actually improves the model performance, right? And if you sort of put everything together, right? Like if you also include the baseline itself as a feature, right? You get a slight additional performance benefit. One of the things that is also worth looking at is this sort of this upper bound that's hinted at here. So what do I mean by this? So the sort of the ground truth that's provided by the DHS is quite noisy actually, and there's at least two sources of noise. So one is it's just a survey, right? It's not an exhaustive enumeration. They just pick some households and ask them some questions, right? But if they had picked other households, then they would have gotten maybe slightly different answers, right? So so this is sort of standard sort of sort of survey noise, and we try to estimate that using so-called sort of bootstrap estimates, where we sort of try to simulate essentially sort of the surveying process in a sense. But then the biggest source of noise comes from the fact that DHS introduces deliberate spatial perturbation or spatial noise. Rather than telling you the true location of the village, let's say, that was surveyed, they perturb it by up to 10 kilometers. Why do they do this? Well, they try to protect privacy of the survey respondents, right? So they they don't specify exactly who they were sort of talking to. Well, somewhere in this area, plus minus 10 kilometers or so. And that's actually quite a significant sort of source of noise. And so basically, we sort of show that these sort of sources of noise combined mean that no method that does not just memorize the data, right, that doesn't just overfit, should be able to explain more than about sort of 84 or 85% of the variance, right? And so with that as an upper bound, right, explaining, more than 70%, if just over 80% is an upper bound, is actually doing a pretty good job in terms of modeling spatial variation. No more than just so this was sort of on the sort of, let's say, spatial resolution, right? You can sort of now do sort of small area estimates. But another area, another aspect that we're interested in is whether we can have demographically disaggregated poverty predictions, right? And so here we're trying now to, so for example, have estimates that look at the education level of somebody. Okay, so how does this work, right? So we train a model on data that is not disaggregated by education level. Right? We just have this model, as I just sort of said, that sort of predicts the wealth index at a given location, knowing nothing about the education level. But this model is then applied to Facebook users matching certain criteria. Right? So for example, here we now apply this model to using only those that have a self-declared university degree. Right? So then we look, for example, what's the iOS usage among people with a university degree, right? And so this sort of model would now, so every data point you see here is a surveyed location in India, right? And you sort of see that in almost all locations, the prediction for people with a university degree, so this is so here, is sort of higher than for people without a university degree. Okay, and that's at least plausible, right? Maybe to some degree obvious, but it's sort of interesting that this sort of, you get this in a sense for free, sort of out of the model, right? And it would be interesting to see whether these data points here, right, where interestingly enough, the model predicts that people without a university degree have a higher wealth index, whether this is just sort of noise, right, or whether there's sort of something, interesting, going on, for some other reason. But at least overall, the pattern at least is plausible, right? Sort of it's sort of plausible and sort of worth looking more at sort of the outliers, whether they might be real or not. Now we try to do the same by looking at gender, right? So again, so every data point here is a sort of cluster location in India, and where we would make a separate wealth index prediction just for women and just for men, right? But now you see something that's surprising, to say the least, in the Indian context, right? Where it looks fairly close to the identity line, right? So that means sort of fairly close to sort of equality, right? And this now is actually not plausible, at least not in the Indian sort of context. Why am I saying this? Well, let's look at data from the Global Gender Gap Index. So this is something that the World Economic Forum puts out every year, right? And this index, India is ranked sort of 149th in terms of economic participation and opportunity out of 153 included countries, right? So with that knowledge, so then, given this huge gap in economic participation, claiming that there's sort of gender equality in terms of, wealth and asset ownership, that doesn't make sense, to be honest, right? And so what's going on here? So what's going on here is a particular instance of the so-called Jackie Robinson effect. So Jackie Robinson was the first African American to play in the Major League Baseball in the US. And for him to make it, despite all the systematic racism, right, and despite all the hurdles that were put in his way, he had to be exceptional. So if you look at his batting average, right, he's one of the sort of all-time greats in baseball. Right? But now, if you then sort of were at that time, right, to look at all the African Americans in baseball, right, all of them had to be exceptional. Right? So if you then were to generalize out to all African Americans, you think, well, all African Americans must be exceptional at baseball. Well, they need to be visible, right? Otherwise, you wouldn't observe them in the same in the first place. And the same is happening with sort of women on Facebook in India. Right? So so there are very few women in India compared to men on Facebook to begin with. But those women that are on Facebook are more likely than men, for example, to have iOS devices. They're also more likely than men to report university degrees, etc. By the way, the same patterns hold for Pakistan, right? So it's also in Pakistan the same sort of thing, that there are far fewer women than men on these platforms, but those women who are on the platforms, again, are more likely to have access to high-end devices, etc. Now, if you were to then generalize out from this sort of small and biased subset to the whole population of all women, right, you come to this sort of wrong conclusion, right? So that all women in general must be doing well, right? And so that's just not plausible. So what can you do? Well, you can limit your model in the features it can use. Right? You say, okay, probably using iOS percentage doesn't work in this context, right? But let's look at only Facebook usage, right? Because it still holds true that areas with higher Facebook usage are areas with of higher wealth index. If you use only this single variable, then you come to a conclusion that's more plausible. Right? So now for every single location, the model, there's now a simpler model, right? So would now predict that men have a higher wealth index than women. Okay, so that's at least sort of the general pattern now is at least plausible. Right? So this is sort of some of the challenges in terms of selection bias when you're dealing with this data. Again, we're happy that this went beyond just an academic study, that in particular through our partners at Thinking Machines, this type of approach continues to be operationalized. So they've since then combined features from Facebook's marketing API with other features, such as from OpenStreetMap or Nightlights, to generate sort of poverty maps that are then also being used by UNDP for their sort of planning of operations. Okay, so the last example I want to mention sort of zooms in on this issue of sort of digital gender gaps that I already sort of mentioned. So again, why are we interested in monitoring digital gender gaps? So let's just look at sort of some stats. So by now, about 60% of the world's population have some kind of internet access. Okay, that's already pretty important milestone, I would say. But of course, this access is not equal. It's not equal across countries, but it's also not equal across genders. So just to give sort of some examples. So in Niger, for every one woman with internet access, you have 3 men with internet access. In Iraq, it's sort of 1 to 2. So far from gender equality, right? But in a sense, both of these countries are positive examples because at least they collect and report this data to the United Nations, right? At least sort of the current state, and you can sort of monitor progress against this. But not all countries are doing. So let's look at this in more detail. So we created a platform called digitalgendergaps.org in joint work with the University of Oxford and with support from an NGO called Data2X. So let's look at some data from this platform. So what I'm showing you here is data from the ITU. So this is the International Telecommunication Union. This is one of the UN agencies that, among other things, looks at data related to internet usage. Right? So they just sort of collect this data and sort of report it by the countries and make it available. So what we are plotting here is the female to male ratio of internet users. Right? So a ratio of 1.0 means sort of gender equality, and a smaller value means that women are at a disadvantage in terms of internet access, right? And here you can sort of see Niger and Iraq, the countries that I mentioned before. Now you see, maybe some expected patterns that generally most of Western Europe is doing, fairly well, as is the United States in terms of, achieving gender equality in terms of internet access. But for many other countries, the data is missing, right? So, for example, India is not collecting or not reporting this data, right? And so now to sort of fill these gender gaps, we're now applying a model, right? So what you're seeing now is a model prediction. So here's a sort of, an online model that uses only data from Facebook. Right? Sort of it looks at the sort of the gender ratio of sort of men to women on Facebook, and now makes a model prediction for the female to male ratio of internet users. Right, and so it learns from the countries where this data is available to make a prediction for the countries where this data is not available. Right, so now if we, for example, make a prediction for India, sort of predicting that there's roughly a ratio of sort of 2 to 3. That for sort of 2 men with internet, so for 2 women with internet access, you have 3 men with internet access. So how well does this model work? So here we're comparing different types of models. So let's look at this online model first, which is what I was sort of showing, before, sort of in the data visualization. So this model, apart from a sort of constant or a model intercept or model offset, whatever you want to call it, has only a single variable, which is the Facebook gender gap. So just the ratio of sort of, men to women on Facebook, corrected for differences in the offline population. So for example, here in Qatar, we have about sort of 70% of the total population being male, driven by sort of construction workers. So correspondingly, of course, we have more male internet users. That's fine, right? Because there's just more men in the population. So this sort of gender ratio is sort of corrected for the offline population. So using this single variable and the constant, we can sort of explain almost 70% of the variance, between for the countries for which we have sort of ground truth data available. So that does pretty well. So what would be a baseline to compare against? Well, a traditional baseline or approach would use sort of more traditional data, for example, the GDP per capita or data from the Global Gender Gap Report. This is what I was sort of showing you before from the World Economic Forum, that looks at things like literacy and economic participation and all these sort of things. Right? And this sort of model picks up some of these features, and in the end, explains, even though it has sort of access to far more features, it actually does worse in terms of sort of modeling the variation across country in terms of internet access gender gaps. And then if you combine the two, you kind of get the best of both worlds, right? Your performance goes up quite a bit, but now you're relying on 2 data sources to be available, right? So the number of countries you can make sort of predictions for sort of drops a bit, right? But again, like sort of, even with a single variable, I started explaining what sort of 70% is quite respectable, I would say. Again, we're happy that this went beyond just a paper, that you can sort of access this data also through the so-called SDGs Today portal, where it's one of 3 data sets on gender equality, with the other 2 coming from the United Nations themselves. Okay. One of the things that I mentioned at the beginning is this recency, right? This data is very sort of recent, so you can really look at sort of current events, sort of on how they affect gender equality, right? So let's look at the case of Afghanistan, right? I'm sure you're familiar that with the sort of fall of Kabul to the Taliban in August last year, right? And there's a lot of questions. So what does this mean, for society, for the country, but also what does this mean related to internet access and the use of sort of social media, right? Will, for example, people stop using, sort of social media, right? Sort of because of, sort of fear of being persecuted. In particular, what does it mean for women, right? On the positive side, there are also stories of, women using social media as a form of protest. So in September last year, right, so it was a social media movement around this hashtag "Do Not Touch My Clothes," where sort of women from Afghanistan would sort of share pictures of traditional Afghani sort of clothing as a sign of protest, right? And so it's not clear which direction things will go. So we've been collecting data from Facebook, coming from Afghanistan now for a while. So let me try to explain what you see here. So here I'm showing data for female Facebook users aged 15 to 19. Right? So these are sort of adolescent girls in Afghanistan. In black, you see estimates of the daily active users, the DAOs, in thousands, right, over time. So in sort of late 2018 and sort of most of 2019, right, the number of users was sort of going down, and that's not particular to Afghanistan, right? Sort of just I think globally, Facebook is using market share to Snapchat, TikTok, and also Instagram. And Instagram is also part of the Facebook family, but for this particular analysis, we only look at sort of Facebook proper. But then they sort of stabilized, in sort of early 2020, and then it has actually gone up, right? So if you look at more detail, this line here, so this line sort of B, this is the fall of Kabul. So this sudden dip here, this is exactly when sort of Kabul fell, right? And this peak here, this is when this sort of social media campaign of "Do not touch my clothes" was ongoing, right? And so during that time, right, sort of Facebook usage among young women went up to levels not seen in many years, right? Like sort of, so it has come down a bit since then, but it's still at levels higher than sort of the pre-Taliban regime, right? Which is sort of interesting, right? And furthermore, it's not just that the total number has gone up, also the share of the total sort of young population sort of compared to sort of boys has also gone up. So now it's sort of gone up from about sort of maybe 20% or a ratio, female to male ratio of 1 to 5, right? Sort of 0.2 to at some point almost sort of 1 to 3, but now it's sort of come down to again sort of maybe just above sort of 1 to 4. Right? So it's interesting, right? So at least so far, probably, so we see sort of sign of a younger sort of mobilizing online. In terms of sort of spatial resolution, we can also, before I showed sort of data at the country level, but again, we can also sort of do this at the subnational level, and currently we're working on doing this in particular in the African context at sort of fairly high spatial resolution. Okay, so to wrap up, so I was, sort of showing you how you can sort of collect such data for Facebook in particular, but it's not just Facebook, right? I could have shown you LinkedIn, I could have shown you Weibo, I should have shown you Snapchat, Google, etc. So anything that has targeted advertising has a platform like this, and it almost surely has an API that you can tap into for collecting such data programmatically. These estimates you get are relatively real time. I mean, they're not like of this hour. I think Facebook probably has a lag of maybe like 1 week or so until sort of they update the estimates of daily active users. But still, 1 week compared to like 10 years for census data, that's essentially real time data. The data you get is anonymous and aggregate. That's good. I mean, we don't want to have an individual level data, right? So I cannot tell you, if you are in the data or your friends or whatever then I don't want to know, right? Like I don't want to have individual level data. And there are a lot of targeting attributes you can use, and the data is collected again free of charge, right? And you have access just as much as I do. Right? And on the downside, Facebook uses some sort of black box, right, to infer some things. But I mean, we know the gender and age are self-declared. That's okay. But then things like countries you lived in, we don't know exactly how Facebook knows, right? And this can change over time, as is shown in the case of Venezuela. The data is certainly not representative, right? I mean, this leads to certain challenges, right? I showed you in the case of India, right? So that when you want to derive gender-disaggregated poverty estimates, right, you have to be very, very careful about how you do this. Facebook, as all advertising platforms, assume a sort of gender dichotomy, right? You're either male or female, and that might not necessarily reflect the reality of everybody. Users patterns change over time, right? So, I mean, you saw this already, sort of Facebook users decline among young girls in Afghanistan, right? Probably due to Snapchat, TikTok, and other sort of things, right? And so that means if your model is working great today, that does not mean it will continue to work great over the next 1, 2, 3, 4, 5 years, right? Maybe over the next year, probably over the next 2 years, but at some point, right, sort of users patterns will be very different, and you'll have to sort of recalibrate your model. Furthermore, you cannot get historic data through this platform, right? If you're after the talk, you're interested in sort of using the statement, hey, Ingmar, please give me data for the last 10 years. Sorry, I cannot, right? And the platform only has data as of today, right? That's when you can launch an advertising campaign. Having said that, we have collected some country level data for the last 3, 4, 5 years, maybe. But this is very, very coarse, just at the country level. Still, if there's of use, I get in touch. And then last but not least, there is a certain risk of misuse, right? I mean, we can identify vulnerable populations, right? Like in particular, migrants in different contexts are sort of, a potential risk of sort of persecution. And though we don't, we cannot identify them as individuals, we can at least create sort of maps of where they're more or less likely to be, right? And that, of course, can potentially put them at harm. Some things we've not discussed, but just to mention, if you're interested in this sort of advertising platform, you can, of course, actually also launch an advertising campaign, right? You can actually now launch a campaign and then do what? So, for example, you can recruit people into a survey, right? You can show an ad to, let's say, young women in Pakistan or so, and show them, hey, we are running a survey, would like to understand your situation, or in this case, we did something related to PayTM usage, right? Like, please come and take our survey, right? Here in Qatar, we are doing something related to cancer screening, right? So where we are sort of looking at trying to improve screening rates for certain types of cancer by basically showing different types of, in this case, it's women related to breast cancer, different types of ads to hopefully improve the cancer screening rates. Another thing that we are exploring is sort of on-demand real-time sensing during disasters, and this is related to what others have done using Twitter data. But okay, so what is it that we'd like to do? Suppose there's an earthquake somewhere, then we would automatically, right, like sort of detect their sort of data on recently detected earthquakes. Then we would sort of launch ads in sort of different parts. In this case, sort of, let's say, imagine different parts of Haiti where there was an earthquake. And then we would ask people things through a poll. So Facebook has sort of polls you can do, right? Like, not which superpower would you have, but, did you have to leave your house? Or, did you have access to running water or something, right? And then in relatively short time, but hopefully best case would be a couple of hours after a sudden onset disaster, we would have like a mapping of where people are more or less likely to, sort of be affected by the disaster, right? And we can sort of do this remotely and hopefully near real time. This is somewhat similar to Facebook's safety check, but it's more flexible. So Facebook also has this option where you can sort of check in after a disaster that you're okay. Here we can be more specific. And then the last slide to wrap up. So, all of this work is typically motivated, right, by this sort of mantra, oh, we need better data, and then, there will be better decisions, sort of, right? And hopefully that's true to some degree, right? But it's not necessarily true, right? Like, if we think of something like sort of global warming, right? I mean, we've had good data for the last 30 years, maybe, at least. But the world still hasn't acted, right? Sort of. So, do we still need more data to convince people? Probably not, right? So it's not just data itself that will now magically cure all ills, right? But still, we hope that at least by having better data, you can highlight certain systematic issues, right? So, for example, gender biases. But just having that data will not fix those, right? You actually then need to have partnerships and other things in place to actually make changes. And just one side of advertising. If you are actually doing research in this area, and you're looking for a venue to attend, consider submitting your work to a special track at ACM Good IT. It's the first year of the parent conference, the ACM Good IT, and so we are organizing a special track on social media analysis for humanitarian development challenges. We have a great program committee with a lot of people from the UN sector as well. Submission deadline is just over a month away, in case that's of interest to you. So yeah, thank you very much, and I'd be happy to use the rest of the time to answer any questions.
Our participants are requested to please raise their hand. Our team would enable the mics to ask the question. The first question is from one of our participants, roll number 0042. Please enable the mic too.
Hi, hello, sir. My question is regarding the data you discussed about the wealth gap in India, right? So, there is a mic distraction.
Okay. Could you hear me? Okay, please continue your question.
Okay. So my question is regarding the wealth gap you discussed in India regarding the gender. Now, in our first inference, it was not consistent with the actual reality of the data, and we had to remove one variable of, let's say, iOS usage. Then it coincided with actually the reality of the ground data. Now, in that case, we had, let's say, an inference of what we wanted to derive, and we had a little bit information that we wanted to, let's say, collect. In that case, that women had lower wealth access, right? Now, does that not fall under confirmation bias? Because we already had a worldview that, or let's say, even the facts that women are, let's say, less well off in that area, and we molded the data or our variables to more conform to that. And in the sense also, it's a two-part question. One, does that not fall under confirmation bias? And two, if we don't have a real world, if there's a situation where we're analyzing the data on social media and we don't have real world information about that, then how do we know that the variables we're using are correct? And let's say the inferences we are indulging from these data are also in turn correct.
Yeah, no, thanks. Very good question. So both ultimately relate to the point of kind of validation, right? Like sort of, right? Like, I mean, it is a bit of a sort of chicken and an egg problem, right? I mean, we try to fill data gaps, right? We sort of try to sort of find things, sort of answer for things that are not known, but because they're not known, ultimately, I mean, we can't evaluate them, right? I mean, because we were sort of trying to fill sort of something that's not known, right? And of course, in some cases, so then, okay, what can we do, right? Like, so in some cases, again, we might have sort of ground truth in some locations, but not in others, right? So we can hopefully validate for some locations, and then if it's working there, hopefully it works in the other locations. That's, for example, what we are doing in this sort of global map that you saw, also for this map of Africa, sort of, so where we have some sort of things that are known, and then hopefully generalize to the other locations, right, where we can't validate those, right? Sometimes the validation is also just of the form of sort of relative trends, right? So even if maybe we're off by the level, but if we collect data across time and things are going up or down, hopefully at least those trends are probably robust, right? Maybe even if the actual level is off, right? But at least if we're sort of saying things are getting better or worse, at least hopefully that's robust, right? Or if there's sort of certain spatial patterns, that it's more here than there or something or so, right? Like hopefully those sort of relative things are sort of robust, right? So this is all more on the sort of on the second part of the question, right? Of course, which is related to the first part of the question. Is it so now the first question, confirmation bias, not necessarily. So there is this sort of this concept of sort of face validity, right? Like when you do an analysis, right, you would at least like to get something that's sort of plausible, like sort of also, right? Like, I mean, of course, there's no way for us to know if the precise value predicted in the end is accurate. That we don't know, because we don't have ground truth that's gender disaggregated, certainly not at that sort of geographic resolution. So that we'll never be able to sort of, at least not with the current data, we'll not be able to sort of validate. Still, I would argue that this notion of face validity is still applicable here. Sort of, so there's very, very strong evidence, not just from this one study, but from a range of sort of other studies that show that there is a significant, sort of gap in terms of having access to wealth and assets in India. So if then our study shows that there's no gap at all, that's just not plausible, sort of. And again, and we have, and again, I can, and we understand why that's, why that model makes that mistake, right? Like so we can sort of, isolate the variables that are at risk, right? That doesn't mean that the model outcome, in the end is sort of true, but at least we are sure that the original one is not true, right? So I think why it is a good question sort of to ask. I think it is important takeaway that you when you do this work, you need some domain knowledge sort of also, right? Because it's very easy to fool yourself into sort of trusting the data too much, right? That you think, oh, I built some model, I applied some machine learning, therefore what I get must be the truth, right? Like sort of, right? But there are so many things that, the relations of data bias or modeling choices or sort of other things that can sort of fool you, right? So I think it's very important to then not have too much trust in the data and then say, you know what, decades of previous work by others is all wrong, and now this analysis shows that there is sort of gender equality, right? So but yeah, it's a good question, but I think I don't think it's a case of confirmation bias.
I said just another question following up with that. All right, I guess it's not a case of confirmation bias, but you discussed about the thing of decades of experience, right? We have previous data available about the situation. In the case of wealth gap in India, I think it's a well-known fact in underdeveloped countries that we have wealth gaps. But let's say in like a business situation or a situation where we are analyzing data where other data sets or other already researched stuff is not available. So how do we know, let's say a data scientist has used the correct variables to model stuff and so on and so forth?
Yeah, that is actually true. And that's a very good question. Like if you're now entering a completely new domain, like so, you have to be very, very careful about this. Okay, so let me maybe elaborate on how sort of humanitarian organizations operate, right? So again, we worked with them on the Venezuelan response, also currently on the sort of Ukrainian crisis, right? Like typically they would never ever fully trust one data set in isolation, right? They would always try to do something that's sort of called triangulation, right? Right? Where, sure, this analysis tells you something, okay, that's interesting, but let's do some other, sort of analysis, like try to find something else, so if that does, and if you do, 2, 3, 4 things, and they all, broadly speaking, tell you the same story, then probably you can have a lot of faith in it. But if they are sort of contradictory evidence, you have to sort of weigh your options sort of carefully, right? Like if you really only have a single bit of evidence, then you probably don't want to jump to conclusions and say, well, this is the only thing I have, therefore it needs to be true, and let's go full steam ahead and not question anything, right? So if it is, so if you are really in a situation where this is the only thing you have, then probably the answer is try to get some other information before proceeding. At least if it's like an important decision, right? If it's just a small decision, I want to add, if it's whether you should spend, I don't know, $100 or $200 on advertising, okay, fine. Then just go with whatever you find, and it's probably not worth validating, right? But if it's really like a life-changing decision, right, like whether you invest millions or not, or whether this is now the state of the country or not, then you probably don't want to rely on any one analysis, no matter what it is, sort of also, right?
So there has been in the industry, it's common for some articles or some, let's say, life-changing articles to present data as valid, right? So I think I guess what I'm getting is data is objective or subjective, so we can't really be sure if that person has gone through a rigorous modeling and rigorous checking of variables to get to that conclusion. And it's very easy to lie with that data if he wanted to do so, if he or she wanted to do so.
Yeah, I think that's correct. And data is also political, right? Like for there's also something, maybe that's obvious, but that are also only sort of learned in sort of practical terms over the last couple of years. Data is used by different players for different purposes, right? I mean, typically it's not just that they are it sort of comes in isolation, and this is just the fact, right? I don't have any agenda. Let me just tell you the facts, and that's the truth, right? I have no other, incentives than just, promoting the truth, right? That's pretty much never the case, right? Like sort of, so there's always some sort of, either conscious filtering or other sort of things driving it, right? So, for example, in the migration setting, right, there are certain things that sort of country offices can put out because they are sort of hosted by the country, so they cannot put out statistics that make a country look bad, right? Because they are ultimately guessed by those countries and they don't want to be kicked out of the country, right? So that, as such, they have to be very, very careful the analysis they put out, right? But then there's sort of region offices that have a bit more flexibility because they're not tied to any one country, but they represent the whole region. They have a bit more flexibility. And then there's even more flexibility when it comes to donors behind closed doors, right? There's maybe one number that goes into like a report that's like on a website and it's very official. But if you talk to people kind of, offline and say, what, behind closed doors, let me tell you how bad the situation really is, right? And then you get another set of numbers, right? So now you might have sort of three different set of numbers for the same situation, right? Like one sort of at the country level, right? That sort of like needs to be approved by the government, one at the sort of regional level where there's a bit more flexibility, and one if you sort of talk to people sort of behind closed doors, right? All of those are probably be based on some analysis that can be justified, right? It's not that they are sort of completely plucked out of thin air, right? But they're used in different sort of contexts, right? And they're all sort of political in different sort of natures, right? So maybe there's sort of, illustrators. It's not that one is true and the other is not, right? But they are sort of created for different purposes ultimately and to tell different stories.
Right. Thank you so much, sir.
Sure. No, thanks. Very good question. Thanks.
If any other participant want to ask the question, please raise your hand. We would enable your mic. Okay. Professor, one question from me. If we are using the digital data to determine the economic indicators and development indicators of any country, then it could become a problem in developed countries where a large population does not have access to the internet connections. So how does this study of using digital data by different platforms, you mentioned Facebook, so how could this become a problem to determine these indicators, especially economic indicators and development indicators in determination of future projects? So does this study seize this problem, and how does this deals with this issue?
Yeah, no, very good. So there's also in the UN setting, right? There's this notion of leave no one behind, sort of, right? Like when you do the analysis and when it comes to sort of representation, that sort of, right? And so, for example, now when let's say we map refugees, right? And based on our mapping, resources are allocated, right? Like sort of, so there's more people here, so we should send more aid there. But then maybe the poorest of all refugees, right, that don't even have any digital connectivity are not included in our mapping, and then those most in need are not given the appropriate resources, right? So that is a real sort of risk, right? Like sort of, right? And of course, we'd like to avoid that as much as possible, sort of. So now, so what can we do, right? Like, I mean, it's our work again. We only see the digital traces, so it's really hard to. So, but as you say, we will be blindsided to people who don't leave digital traces because we only analyze digital traces, right? So all we can do is hopefully work with partners who have more expertise on warning us about hindsight or sort of short sight or blind spots, or sort of who will be careful enough to triangulate with other data sources, right? That hopefully augment these different things, right? We can also do some sort of analysis where at least we sort of look at whether certain things, let's say, sort of correlate, right? Sort of, so for example, maybe if we have some evidence that we are, that we are underreporting migrants in areas with lower with lower iOS usage, let's say, like, right? Sort of, so where we have another, so we have a second data set that tells us something about distribution of migrants, and then we sort of compare the two and we sort of see where do they differ and what might explain this difference, right? And if then we sort of see that iOS usage, somehow corresponds to the sort of our data maybe missing certain people, right? Then that at least would give us a clue that there seems to be like a correlation between sort of risk and underrepresentation, right? But if on the other hand, there's sort of these two seem to be, sort of discrepant in ways not correlated with device usage, then that would give at least some plausibility that we're not sampling or over-undersampling based on sort of wealth, right? Like sort of, we might still be over-undersampling based on other characteristics, but maybe not necessarily sort of wealth explicitly, right? So that could be one thing to at least explore if there is a sort of a risk, right? In other settings, actually the who's not on the platform becomes the signal, right? So when we do this work on digital gender gaps, we explicitly look at, right? You could sort of look at not who's on the platform, but who's missing. Like we sort of look at the gap, right? So in that particular case, I think the fact of not being on the platform is in a sense the signal we are using, right? So in that particular study, I think those concerns do not necessarily apply, right? But it's definitely also true that these sort of signals are not one size fits all, and they should not be used in all contexts without more validations. For example, we've done some work that compares the value of Facebook data for mapping poverty against the value of using satellite imagery for mapping poverty, right? I mean, again, there are other data sources you can use, right? And in a nutshell, there seems to be some sort of complementary strength, where maybe in urban areas you're doing better by using Facebook data, or sort of combining the two, but in rural areas, you're probably doing better by using satellite imagery, right? Sort of also, right? And so it's also not necessarily like a sort of one size fits all, always use this data in all contexts, right? But maybe in an urban context, right, with good internet connectivity and fairly high social media usage, maybe that's a valid data source to add to your mix, right? But maybe if you're in a very rural context with, hardly electrification to begin with, probably don't immediately jump to using Facebook data for your models, right? There are probably other data sources you should use first, right? But absolutely, but if nothing else, be sure to question your data. Where are blind spots? Who's missing? Who's put at a disadvantage? Who's over or underrepresented? So those are definitely very, very important questions to ask.
Thank you, Professor. I have another question. In one of your slides, you mentioned about the poverty and wealth analysis, where I think USAID sponsors one of the surveys. So for the poverty and wealth analysis. So how does this is an effective method to collect data from respondents about their wealth assets or ownerships? Because a lot of people could hesitate providing their data for these kind of service. So is this service or these services are kind of effective for the poverty and wealth analysis? And does this include a larger participants to analyze these analyses?
Yeah, no, again, good question. So my understanding, so I'm not an expert on sort of survey methodology, but my understanding is that sort of what the DHS does is as good as any survey data you ever get, right? So this doesn't mean it's perfect, right? But it's they're certainly very careful also for looking at sort of non-response bias. So if you look at the sort of micro data, there are, for example, weights assigned to certain respondents, right? Where they basically sort of try to, as is sort of frequently done, give more weight to people who are less likely to respond, right? Like if they, for example, generally have some evidence that in this village, people are less likely to respond, right? Or if, I don't know, maybe they have information on who responded at the door and it's I don't know, maybe it's an older person and they see, oh, from older people, we're less likely to get complete answers or something, then they would sort of give more weight to the few old people who did respond, sort of also, right? Like if there's some sort of evidence that they are sort of understood. Of course, that's not, that's not perfect, right? I mean, there's like, I guess the best example is, right, if you wanted to study people's willingness to respond to surveys, right? Probably in 100% of the surveys, you'd get, people are willing to respond to surveys. Right? Yeah, of course, right? I mean, right? So I mean, so the question is now, does the sort of non-response correlate with something that you can't correct for by giving more weights to certain demographic attributes, right? And maybe there is, right? Maybe wealth by very paranoid people is not appropriately measured, right? Because maybe, they will, maybe that's orthogonal to demographics. You have old paranoid, you have young paranoid, and their wealth is just not appropriately measured because they don't respond to service. So that's certainly a possibility. But again, punchline, what the survey does is as good as what any service, sort of survey in the world sort of does. So it's certainly not perfect, but I think it's still very, very good.
Thank you. And another question regarding the potential of TikTok. It is also a very emerging platform and beating actually Facebook in competition. And it is also very popular in the developed countries. So how do you, Professor, see the potential of TikTok in the future for the similar kind of studies using digital data to support global development?
Yeah, very good question. So in a nutshell, anything that has an advertising platform, has data like this sort of. So I've not looked at TikTok specifically myself, but I have looked at Snapchat, Weibo in China, Contact here in Russia, Instagram, which is part of Facebook, so it's the same interface, Google, etc. So anything that has a targeted advertising has a platform like this. So as such, in terms of the general approach, as long as TikTok has an advertising platform and as long as they provide certain attributes for advertisers to target on, there's nothing that would keep you from doing something similar using TikTok data So, for example, we have done work with UNICEF where we look at teenagers in particular. And of course, for teenagers, at least when we did the study, Snapchat and Instagram were more relevant than sort of Facebook proper side. And so there, for that work, we looked at data from Snapchat and Instagram specifically. So I don't have enough TikTok specific expertise to tell you, use it in this country or don't use it in this country or only use it in this context. But what I can definitely say is that I'm pretty sure is that the general approach would work just as well. It's just as of now, in terms of global penetration, especially across all ages, Facebook is still the biggest game in town. So that is in most contexts, Facebook, at least as of today, is probably still the first, the platform of sort of first choice. Now that will not be like this forever. It's likely to change, and it might also be different in demographic subgroups, in particular for young people or so. But at least at a global level, for across all age ranges, as of today, I would still suggest to start with Facebook.
Thank you. There is another question regarding the digital. So my question is how far we are when in future a lot of countries will be using digital data by collecting these platforms to determine their economic indicators and their development goals, and how far we are. Is these kind of studies are going to replace traditional data gathering and data collection techniques like consensus to determine these goals in future? So what's your opinion?
It's a very good question. I don't think they will replace traditional data. If nothing else, at the moment, most of these approaches need some sort of ground truth data for either model fitting or calibration or whatever you want to sort of call it, right? But I think what many countries are looking at whether such data could be used in the sort of off-census years, right? At least sort of to simplify, like at the moment, every time you do a census, you have like a perfect snapshot of your population and the economy, like everything is sort of captured. But of course, again, that's very expensive to do, so you don't do it like every year, And so, but this gives you like a sort of like one snapshot in time to kind of calibrate against, right? And then hopefully in the years until the next census, maybe you can do something that updates more frequently or sort of has sort of other advantages until again you have another sort of full round of census to sort of recalibrate. But in particular during COVID-19, right, there was a lot of interest in COVID has changed the economy completely, right? So how can we have something more real time, right? Until not waiting another sort of 10 years, right? Whether it is this particular data, that I'm not sure, right? I think people are there's probably more global development or more investment in things such as mobile phone data, sort of CBR data, sort of, right? Like sort of, so for example, related to mobility in particular, or there's a lot of interest in satellite imagery. There's also more and more interest in sort of, let's say, things like scanner data. So barcode scanner. So if you scan something in the supermarket, that data is recorded, right? And so you can you use that data, for example, monitoring inflation or sort of consumer behavior. If you have this, for across all supermarkets, there's more efforts in digitizing administrative records, right? Like sort of, let's say, how many people go there. For example, I'm sure your universities have, a lot of data theoretically, but it's probably not necessarily being shared, with others, sort of as much as it could be. I'm not saying it should be, but at least it could be. So if you wanted to understand sort of the state of situation, so punchline, I think there is more and more, and at the moment it's still mostly at the sort of pilot stage. So, for example, within the if you search for United Nations Big Data Working Group, you'll see there's a lot of effort in sort of trying to sort of do like proof of concepts for sort of some countries, sort of to show the value that then hopefully others can replicate, right? So I think so we would see more and more going forward. I mean, I don't want to put like a timeline and sort of, and I don't think it will ever replace existing things. Among other things, a challenge relates to having something sort of long-lived that's stable, right? I mean, like the idea of counting people and asking them questions has been around for thousands of years, right? I mean, there were censuses done like literally thousands of years ago, right? I mean, it's been proved like a very, very robust data collection method, right? You could knock at people's doors, you ask them questions, and then you sort of tabulate that data, right? So that would probably not go away. Now, mobile phone usage is also changing, right? So if you look at how people, if you derive some modeling data from how people make phone calls, I mean, again, that changes right now. People, I never ever call my wife anymore, not because we're not in contact, right? But we're using WhatsApp, right? We're sort of we're sort of in regular contact over different platforms, right? But my mobile phone operator would not see that anymore, right? Like a couple of years ago, they would have had a signal on that, right? So all of these digital traces are so much in flux, right, that they are changing. Or even satellite imagery, right? Like night lights are typically a strong signal for economic development, right? But now at the very high end of sort of the richness or income, there's now more and more effort to sort of avoid light pollution, right? Like, so that means that, at some point you might even try to have now less light admitted at night, right? Like sort of, so even this very, very simple pattern, will probably change over time, right? So long story again, so I don't think there would be any replacement of this very robust, let's ask people questions and count them, but hopefully there'll be some augmentation for more real-time estimates, not necessarily precise sort of counts, in sort of off census years.
Thank you. One last question before we conclude. And which international agencies support these digital data to study for the global development? And how could we be in touch with these agencies? So based on your experience.
Yeah, so also a very good question. So in essence, it's almost all of them, although they are sort of, let's say, degree of data readiness varies. Let's say so. I think I would say the World Bank is probably fairly advanced in some of their models, in particular when it comes to sort of using satellite imagery, and I think maybe also things related to mobile phones. And then there are certain pockets sort of, like for example, UNICEF has an innovation unit which is quite strong. There are certain dedicated, not agencies but organizations. There's one called UN Global Pulse, which is a sort of think tank, sort of basically situated in the sort of UN HQ, which does a lot of sort of these sort of big data studies and explorations. So yeah, and then there are a lot of runners. How to sort of get so there are also sort of let's say bridge building organizations. So for example, there's an organization called Data Kind that tries to connect people with data science experience with problem owners, not necessarily in the UN sector, but partly they are in the UN sector, can also be different sort of NGOs or sort of, right? Where an NGO might say, oh, I'm interested in avoiding poaching in national parks in Pakistan, right? And they have some sort of data related to poaching incidents, and they would like to build some model around this sort of, right? And so just making sort of, well, actually, I'm sort of making this up, but such cases do really exist, right? And then through data kind, they would sort of try to connect data scientists. There are also other programs such as data science for social good. So that's something that was started at the University of Chicago. It's now led by Carnegie Mellon University by Rayat Ghani, which is it's a more smaller but more focused program. Again, sort of trying to connect sort of students with project owners. Apart from that, I mean, feel free to also, contact me if you have a certain, sort of, let's say, topic that's particularly close to your heart, right? If you say, oh, I care deeply about topic X, Y, Z, maybe I can help you sort of connect to people who have a sort of, actually data analysis need in that area. But yeah, so I think there's some expertise across the UN sector, but very densely concentrated in World Bank, but also in particular UN Global Pulse in the UN sector as a sort of leading think tank.
Thank you so much, Professor. That's all we are having. One question from Mr. Bilal. Please enable the mic, one of our participants. Mr. Bilal.
Yes.
We have exceeded. We have exceeded the time limit, so we would like to.
That's fine. Yeah, I will try to be there.
Yes.
Many object the data collection by these platforms are on the ethical grounds. Do you think that will limit the scope of data collection by in future if there are any legislation or if this point of view prevails?
Yeah. No, it's a very good question. So the most recent example is, of course, what iOS did. Right? Probably you're also familiar. So these platforms collect data in various ways. But in the most direct ways, it's what you do on the platform itself, right? Like if you create an account and you declare to be a young man, that data is sort of held by, let's say, Facebook, right? And there's nothing that Apple can do about that or sort of. But then these countries also collect a lot of third-party data through sort of cookie sharing about sort of other things. So, for example, if you visit a website that, for example, has Google Analytics, right? So then, Google would know you visited the website. Or if it has Facebook Analytics or like a login with Facebook or like us on Facebook button, again, Facebook would know you visited the website. And I think there was a recent estimate, I think from 2020, if I'm not mistaken, that estimated that sort of almost half of all website visits are sort of recorded by Facebook, right? Like, and even if you don't have a Facebook account, I think it's still like 40%, right? Sort of, because there's still sort of through cookie sharing, sort of, right? And so now, some of this sort of data collection can certainly be limited, right? And is being limited, right? At the moment, iOS is in particular sort of taking actions to limit that data. Now, in the work that I showed so far, this data is not being used. So this would come in more if you look at sort of the interests expressed, right? Like if I want to see, are you interested in, I don't know, satellite imagery or something, I don't know, whatever. Then, maybe Facebook is not the best source to, you read about satellite imagery, but you go to some other website and they, have some cookie sharing with Facebook, sort of, right? And then this could be sort of affected by iOS usage. Now, so will this data be more restricted? Probably, possibly, right? I think I share your opinion that probably there's more. The direction goes to sort of more privacy, and even Facebook themselves are limiting some of the targeting attributes, not age and gender and device type. I think that those will always be there, but they have sort of, for example, removed a certain targeting related to religious content, right? So I previously you could target people essentially based on their religion, not exactly, there's an oversimplification, right? But whether somebody is interested in, let's say, the Holy Quran or kosher diet or I don't know, some Hindi festival or something. So right? That's no longer possible as of earlier this year, and so those sort of things I think might disappear. Will the whole ecosystem change? I don't know. At least not. I really don't know. There's certainly efforts, right? Sort of, can we create something where the data is sort of more directly owned by the user, right? Where you have some sort of, let's call it a pod or something that is your data, and you sort of go with this data to different platforms, and you can sort of control who accesses this data, and maybe there's a micropayment, right? Like every time you give access, you get like a cent or something, or sort of so. So far, all these efforts are fairly experimental or grassroots. It would be very interesting to sort of see if any of those sort of is to sort of take off. At least in the foreseeable future, I think people are just so used to the ease and the just give me my stuff for free. Sure, I'll click any yes, allow. Just show me the content. Don't make me sort of think too hard. Right? Just show me the kittens, and yeah, sure, you can have all my data. So I don't think that's changing, anytime soon. Again, there might be some changes on the fringes, like related to sort of the interests and some of the sort of third-party tracking that I think will be more limited. But the sort of the core, I think, is likely to remain intact, at least in the foreseeable future. It might change to a different platform. Right now it's TikTok, maybe not Facebook. That can certainly happen. But I don't think targeted advertising as the business model on the internet is disappearing soon.
Thank you, Professor. That's all from the question and answer session. We are heading towards conclusion. On behalf of Department of Computer Science, GCU University Lahore, Pakistan, GCU University Lahore, Pakistan, and in particular GCU-ACM student chapter, we would like to thank you for joining us today and delivering this insightful session, and looking forward to have you with us for more future sessions. Thank you very much.
Great. Thanks all of you for joining. Yeah. Have a nice day. And Ramadan Kareem. Yeah.
Thank you.